Now, square root based sequence. What is the sequences which are square roots based? If s1 is greater than to 0 by arbitrary and define sn plus 1 is equals to 1 by 2 sn plus a upon sn for n is in natural number. This is the square root based sequence, right? Because the limit of this sequence is square root of a. So we should prove that it is a convergent sequence which is converges to root a. How do you show that it is a convergent? First, we show that Sn square is greater than or equals to a for n is greater than or equals to 2. Firstly, we show that this is Sn square is greater than or equals to a. Now, if you have this type of terms sequential relations, then we take it as Sn square minus 2 Sn plus 1 Sn plus a, which is equals to 0. As Sn square plus a minus 2 Sn into Sn plus 1. So this is the square root equation. This makes as it has a real root. So after taking this discriminant, what is the discriminant of this? Which is 4 Sn plus 1 square minus 4a. And now it is always non-negative. It is always non-negative. This gives you Sn plus 1 whole square is greater than or equals to a for n is greater than or equals to 1. To see that Sn is ultimate decreasing, we note that for n is greater than or equals to 2, we see that Sn minus Sn plus 1 terms, right? For decreasing and increasing, showing that Sn minus Sn, what is Sn plus 1, which is 1 by 2 Sn plus a upon Sn, right? After solving this gives you 1 by 2 Sn square minus a upon Sn, which is greater than or equals to 0, right? So if it is greater than or equals to 0, this implies that Sn plus 1 is less than or equals to Sn. So this implies that this is a decreasing sequence. Sn is a decreasing sequence. But by monotone convergence theorem, this implies that if it is bounded by a and it is monotonic decreasing sequence, then by monotonic convergence theorem, this implies that the limit of this sequence exists and it is convergent. Now let the s is equals to limit of Sn exist. Let s is the limit. Put it in the relation between Sn plus 1 is equals to 1 by 2 Sn plus a upon Sn, right? So it gives s is equals to 1 by 2 s plus a upon s, which is s square is equals to a and s is equals to root a. This is the final solution for this.